but I'm just going to start at the beginning. So at the top is the function, and look what I did next, okay? We have the number 3 multiplying something that involves both x and y, and then times e to something, and what's in the exponent of e also involves both x and y. So I simplified that down visually by calling the expression x minus 2 squared plus 3y squared, I called it star, and the exponent of the e, I called it box. And so z then is 3 times star times e to box. So when I then found z sub x, I put the 3 with the star function, and I do have a product rule that I have to follow. Okay, so 3 times star is multiplying e to box. So first, so this is first, and then times derivative of the second. So derivative of e to box will be itself, times the derivative of box with respect to x. Okay, because we're taking the derivative with respect to x. So notice over here, I defined star and box, and then I also made a little chart outlining what the derivative of star would be with respect to x, what the derivative of box would be with respect to x, what the derivative of star would be with respect to y, what the derivative of box would be with respect to y. And then I kind of kept them over there for when I needed them. So then from there I could kind of just plug things in as I needed. So again, first times derivative of the second plus the second left alone, and then this is the derivative of 3 star with respect to x. The derivative of star with respect to x is 2 times x minus 2. So then I looked at that and I noticed I could factor a 6 out, and an e to the box out, and an x minus 2 out, and then I factored everything out of this, leaving me with a 1, and then I factored everything out of this except for the negative star. So that's my trimmed down derivative of z with respect to x. So then I did the same thing for y, and so this is what we get with respect to y. And I guess I found my critical values later, further down. So this is what we were working on at the end of class. We were working on the double derivatives. So z double x, I went back up here, and I still have a product rule within a product rule, but with it cleaned up, it's a little easier for me to keep track of what I've done and not done. Alright, so we're taking the derivative with respect to x. Why don't we talk through y, because that was the one you guys were doing, and so those of you who did it, you can kind of compare. Okay, so here's our z double y. So z sub y is up there. And again, I do have product rule within product rule, but you know, with it cleaned up, it's a little easier to keep track of things. So I, first of all, grouped this as a first function, and then this as a second function. That's how I initially read it. So that's why I have this written down with nothing done to it, because remember, product rule, you leave one alone, and then multiply by the derivative of the other one.
I have a question. So, for the e, since it's e to the negative something, can we put it down and then do a product rule on the top, then a quotient rule for both of them?
you put it down and then do a product
Like,
rule for the top and
it's-
then a quotient rule.
E to the negative.
Oh.
You get it.
Well, I mean, anytime you have a negative exponent, you could look at it as a quotient
That's what I'm saying.
or,
Don't make it simple.
I don't know, well, I mean, maybe it does, I don't know.
And once you do that, you've got six Y there, and why not just distribute the six Y through? And then you've got just a quotient of it.
Okay, if I'm doing quotient rule with respect to y, then I would have denominator times derivative of the numerator. I have to do product rule here, so I would have first, and then the derivative of star with respect to y is six y minus, or plus star, which was x minus two squared, I don't. Like, if you left it with the stars and the boxes, that would be e to the, what it would be opposite of what I had for the box. But, so was your question really, is it the same, or were you just pointing out that you did it differently?
Yeah, funny about that.
Okay, well then don't phrase it as a question, just say, I did it differently, I
I just
rewrote
wanna
it as
make
a
sure that
quotient.
I did it right. Or is it, like,
Well,
I was just wondering if you can do it.
okay, again,
that way.
I can't answer that without really detailed proofreading all of your work. I mean,
Just one.
it's a basic Calc 1 topic, that a negative exponent can be written in a denominator, or you could write it as product. And so you could do lots of products, lots of problems, either as a product rule or as a quotient rule. In terms of did I do it right, I'd have to look at your work, but like you learned in Calc 1, you can do product rules and quotient rules depending on how you write it. Okay, so if you had been doing yours as a quotient rule, I probably only this is gonna show up in the denominator. But I don't have it squared, which probably means that you had a factor in the numerator that could be factored out that would have canceled one of the squares in the bottom. Okay, I feel like we got sidetracked instead of us being able to talk through what I was trying to show you. So Are you guys, like, understanding the idea of how I made little symbols or variables to represent a messier thing? So that you can have like less stuff to write down, or are you guys kind of recognizing that idea? Okay, so then, when we do go, and I did the same thing with Z, X, Y. I guess I did that later on in the problem. I redid the part where we found our critical points, but we did that yesterday. Okay, so these are the same critical points we found yesterday, and the logic we used is the same. I just have it outlined again. So when you go back to plug in the numbers, so like for each individual point, I then am individually calculating Z double X and Z double Y and ZXY. And so when you focus on the fact that, you know, for example, for the point 2, 0, if you remember that this was star and this was the box, and then you're plugging things in here, if I plug 2 and 0 into star, I will get 0. And if I plug 2 and 0 into box, I get 0. So at this point, both of these messy expressions turned into 0. So I have 6 times e to the 0, and then a whole bunch of stuff turns into 0. We end up getting 6. I think we got that yesterday. But we had not yet computed Z double Y. So again, if you follow through Z double Y and you plug in 2 for X and 0 for Y, what was the star is 0 and what was the box is 0. And so you end up getting 18. Z sub XY, which I know I didn't talk through how I got it, but basically you have a product rule, and inside the one product you had another product. But again, the box is 0, the star is 0, so when you plug in 2 and 0 for Y, you end up getting 0 for the whole thing, because you plug 0 in right here for Y, that makes this whole thing 0. And then when I plug 0 in for Y here, it makes this whole thing 0, and that was multiplying this, so the whole thing is 0. So your D, so remember that the definition of D is the second derivative with respect to X multiplied by the second derivative with respect to Y minus the second derivative with respect to xy squared. You get a positive value. Because the value is positive, I know that I have a minimum or a maximum. Okay, I know it's going to be one or the other if your D value is positive. Because my second derivatives with respect to x and y are both positive, again, if D is positive, we automatically know they're of the same sign. But since I worked it out earlier, we know they're both positive. Because they're both positive, you have concave up in both directions, so you hit a minimum point, and the minimum point has x coordinate 2, y coordinate 0. If you plug 2 and 0 into the original equation, you end up getting 0. So this is z when you plug 2 and 0 in for the x and the y, the original function. So then I went through that same process for the other critical values, and this is not uncommon that for the critical values, lots of stuff ends up canceling out. So your arithmetic ends up being pretty clean. And again, that's not uncommon from the nature of, the derivatives equaling 0 at those places. Because a lot of factors that were in the original derivatives end up being in the second derivatives. So if you plug 2 and 1 in, some of the expressions that were x minus 2, they turn into zeros, but the
the exponent on the e, it turns into -1. And so for z double x, I end up getting -12 times e to the -1. And for z double y, I end up getting -36 times e to the -1. Both those are negative values. This ends up being 0 again. And so d is a negative number times a negative number minus 0. I get a positive value. Again, that tells me I have a min or a max. This time it ends up being a maximum because my second derivatives with respect to x and y are both negative. So I have concave down because the second derivatives are negative, and that tells me I have a maximum. And the maximum is technically at x2, y1, and then if you plug both of those into the original function, you get 9 times e to the -1. So that was 2, 0, 2, 1, 2, -1. Again, the more you've got exposed to the functions, you kind of know what's going to happen. So notice I have less writing because I kind of already know what turns into zeros and so forth. Because we were squaring the x minus 2 and the y, whether I plug -1 or +1 into the exponent on the e, I still get the same thing. So I actually end up getting the same values for z double x and z double y as I did at the point 2, 1. So that maximum ends up kind of paralleling the other one. And then the other two are saddle points. And so when we plugged in the 3, 0, the exponent on the e turned into -1. The star value would have ended up being, 1. So that's where that 1 is coming from. So notice with this time though, the z double x ends up being -12 e to the -1, and the z double y ends up being positive. So without even calculating d, I mean, I did so just because I was trying to go through the technical process, but without even calculating d, because the second derivative with respect to x was negative, and the second derivative with respect to y was positive, I already know I have a saddle point. Because if one is negative and one is positive, then you're going to have concave down in the x direction and concave up in the y direction, creating your saddle point. Okay, so d ends up being negative because you're multiplying negative times positive. The zxy still is 0 for the points we're plugging in. And then if you plug 3 and 0 into the original function, you get 3 e to the -1 as the z value. And then the last point was 1, 0. And when you plug 1 and 0 into z double x, you get another negative. In fact, it's the same as what you got up there. And you get a positive for z double y. It's the same as it was for 3, 0. And so, and again, that's not surprising considering how symmetric the graph looked. If we go back and look at that graph, these 2 points are kind of, you could tell they're at the same height. My 2 saddle points are at the same height. And then the minimum is down in the middle. So we had 1 minimum, 2 maximums, and then these were our 2 saddle points. All right? So again, in terms of example points coming up, it was a nice one to have because we had some maximums and minimums of saddle points. It was messy in terms of the algebra, but then it brought up how you could get through messy algebra by substituting with variables or symbols to make it look a little cleaner. All right, so moving on to the next example. Again, for our class discussion, I have given you these graphs, but you're not necessarily always going to have the graphs. I know Issa the other day had asked, well, how are you going to know if you found all the critical values? You kind of just have to logically look at the algebra to figure out if you exhausted all possibilities. It's helpful to have the graphs. So looking at the graph here, I can tell there's one maximum. My contour also points out that without any numbers on the contour, I can't tell if that's a max or a min, but I can tell that there's one point that ends up being a max or a min. Looking at the graph here, I can tell that it's a maximum. Again, the derivative ends up being kind of messy on this one, so I will try to, the reason why I didn't run off the other, because I noticed on one of the problems, there was an arithmetic error, and I didn't want to run the whole thing off until I fixed that one problem. Autofocusing enough. Okay, so our initial z sub x and z sub y, in this case I did not do quotient rule because when your numerator is just a constant, you kind of have extra steps if you write it out as the quotient rule. So when my numerator is just a constant like it was here, I usually write the denominator with a negative exponent. So that's what I've done. And so the derivative with respect to x, you're going to subtract 1 from the exponent. So instead of it being -1, it's now -2. And then the derivative of the inside with respect to x is 2x minus 6. So that's where this 2x minus 6 is coming from. So then cleaning that up, I factored a 2 out of 2x minus 6.
Yeah.
And should my 10 be in the,
Should be in the numerator, not the.
yeah, so it should be. What happens when somebody is talking?